Welcome to the deep dive. Today we're cracking open some material you shared with us.
That's right. It's excerpts from Beginning JavaScript 5th edition.
Yeah, exactly. And our mission really is to pull out the core ideas about JavaScript programming from these early chapters.
Think of it as a solid starting point,
Hmm.
getting those fundamentals down for web development.
Absolutely. Because let's be honest, programming can seem a bit daunting sometimes.
It really can. But we're aiming to uh, break down these core concepts, make them clear, focus on those aha moments.
And hopefully avoid getting bogged down in like super technical jargon right away.
Exactly. We want to make it engaging.
Okay, so kicking things off, what is JavaScript fundamentally? The source says computers don't just understand it.
No, not directly. It needs an interpreter. Think of it like a translator.
A translator.
Yeah, translating the JavaScript code into machine code, the binary, the ones and zeros that the computer's hardware can actually run.
And this happens when it...
Every single time the code runs. That's what makes it an interpreted language.
Right, so it's different from compiled languages.
Yeah, exactly. Compiled languages do that translation step once up front. JavaScript does it on the fly.
The book mentions others like this?
PHP and Ruby are mentioned as other interpreted languages, just to give some context.
Okay, got it. So how does this JavaScript actually, interact with a web page?
Yeah.
The ones we see.
Well, the source explains that web servers hold the web pages, right?
Right, you store the files.
And when your browser asks for a page, the server sends it over using HTTP. That's the delivery system.
And then JavaScript comes into play.
Precisely. The JavaScript code itself is actually embedded, like woven right into the HTML of the page.
How is that done?
Using these special tags, script tags, you put your JavaScript code inside them.
And the browser just reads it.
Yeah, it executes the script line by line from top to bottom, like following a recipe.
Okay. Does my browser just do this automatically?
Pretty much. The book mentions that most browsers, like i.e. Chrome, Firefox, are named to have JavaScript support turned on by default.
But you can turn it off.
Apparently, yes, in most of them, except maybe Firefox, according to the source. Worth checking your settings if you're curious.
Interesting. And can the JavaScript live somewhere else, not just inside the HTML?
Oh, definitely. You can put it in separate files and just reference them from the HTML.
Okay.
Keep things cleaner, especially for bigger projects. Though our current source doesn't detail how just yet.
Right. So we know what it is, where it lives. What about the stuff it works with? Data.
Yeah, data. The source defines it simply as, information in computing. Numbers, text, dates, times, all that stuff.
We're starting with...
Just the basics for now, numbers and text.
Okay. And this leads to data types.
Exactly. JavaScript categorizes this data. Numbers are one type, text is another. It mentions object as a more complex type. We'll see later.
And how does JavaScript handle these types compared to other languages?
Well, it's quite flexible. Some languages are strongly typed,
Meaning
you have to explicitly say what type of data a variable will hold, and you can't easily mix them, like adding a word and a number.
Oh.
JavaScript's more relaxed about that.
So let's look at those first two. Numbers. It's pretty straightforward.
Yeah, just your standard numerical values.
And text.
That's called a string in JavaScript. It's just any sequence of characters inside either single or double quotes.
Either works, single or double.
Yep. And the book gives a neat tip. If you need a single quote inside your string, just wrap the whole string in double quotes.
And vice versa.
Exactly. But if you have to use the same quote type inside and out,
Then what?
you need an escape sequence. Basically, put a backslash right before the quote inside the string.
Like he said hi.
Perfect example. That tells JavaScript the inner quote is part of the text. It also mentions there are other special escape characters, like in HTML.
Okay. What's next after numbers and strings?
Boolean. Sounds fancy, but it's just true or false. Yes or no?
Ah, for making decisions.
Exactly. It's the foundation of Boolean logic.
Yeah.
Named after George Boole. We'll see it in action-making program choices soon.
So to use all this data, we need to store it somewhere.
Right. That's where variables come in. Think of them as labeled boxes in the computer's memory.
Okay.
You declare them, like creating the box, and then you use the equal sign, the assignment operator, to put a value inside.
And the source says JavaScript variables are flexible.
Very flexible. They can hold any type of data text, numbers, booleans.
And that type can change.
Yeah. This is quite different from many languages. A variable holding text could later hold a number.
The book has a try it out for this.
Conceptually, yeah. It describes creating a variable, maybe putting text in it, then a number, and using alert to pop up a message. showing the current value.
Alert. That shows a pop-up.
Yep. Just a simple way to display information. The example also shows assigning the value of one variable to another, basically copying the contents.
Okay, variables store data. How do we manipulate it?
Using operators, we start with the basic math ones.
Plus, minus, multiply, divide.
Exactly. Plus, plus, plus. Pretty familiar stuff.
Then it gets into shortcuts.
Yeah. Programmers love shortcuts. The increment, plus, plus, and decrement operators.
Just add or subtract one.
Yep. Quick and easy. That's where the C++ joke comes in. C++.
Ah.
And there are more shortcuts.
Yeah.
Compound assignment operators.
Like plus.
Right. myvar plus 6 is just a shorter way of writing myvar or myvar plus 6, and same for back, etc.
Saves typing.
Definitely. The source also mentions operator precedence, briefly.
Like order of operations in math. PEMDAS?
Kind of like that, yeah. Some operators get evaluated before others,
Right.
but you can always use parentheses to control the order if you need to.
Makes sense. So how does the script talk to me, the user?
Good question. The source introduces a few functions for that. First, prompt.
What does that do?
It pops up a box asking the user for input, like asking for your name.
An alert, we mentioned.
Yeah, that just displays a message to the user in a pop-up.
Okay. Any others?
Document.write. That one actually puts content directly onto the web page itself, not in a pop-up.
And if you have text strings, you can join them.
Yep, that's string concatenation. You just use the plus operator.
So like hello plus O plus world.
Exactly. The example combines a greeting, a space, and maybe the name entered via prompt.
What if the data isn't the right type, like text that should be a number?
Converting data types. The source introduces parsent.
Parse integer.
Right. It tries to turn a string into a whole number, an integer.
And if it has decimals?
Then you use parse float. That tries to convert a string into a number with a decimal point, a floating point number.
Can you use these on variables too?
Yep, directly on strings or on variables holding strings.
What happens if the string isn't just numbers, like 123 ABC?
Good point. Parsent usually just takes the number part from the beginning. So 123 ABC would likely become just 123. It stops when it hits a non-number.
Okay. Now what about organizing lots of data, like a list?
That's where arrays come in. They're ordered lists.
Like a shopping list.
Exactly.
Yeah.
Each item has a position, an index. But here's the key thing.
What's that?
Array indexing starts at 0.
0, not 1.
Nope, 0. So the first item is at index 0, the second at index 1, and so on. It trips up beginners sometimes.
Feels weird, but okay.
You get used to it. Arrays are really flexible too. They can hold lots of items, or just a few. You don't need to decide the size up front.
Can they hold different types of data, like text and numbers, in the same list?
Absolutely. You can mix and match types within the same array. Very handy.
The source mentions multi-dimensional arrays.
Briefly, yeah. Think of it as lists inside lists, like a grid or maybe storing info for multiple people, where each person's details are their own list inside the main list.
Okay, complex structures. Now, how do we make programs smarter, make decisions?
Using conditional statements. The most basic is the if statement.
If something is true, do something.
Pretty much. You write if, then a condition in parentheses, then the code to run inside curly braces.
Those curly braces are important.
Very. The book stresses you should always use them, even for a single line of code, just to avoid errors or confusion.
Okay, and if the condition is false?
Then you can use an else statement right after the if block. That code runs only when the if condition wasn't met.
If this, do that, else do something else.
Exactly.
How do we write those conditions? Like, is age greater than 18?
With comparison operators. For greater than, for less than.
And for greater, less than, or equal to?
Yep. And for checking if things are equal, note the double equals.
Not just one equals.
Right. Single equals is for assignment, putting values in variables. Double equals is for comparison, checking if they're equal.
Gotcha. And for not equal.
Correct.
What if you need to check multiple conditions? Like, if age is over 18 and D, they have a ticket?
Logical operators. ND, both sides must be true.
Okay.
Is OR, at least one side must be
If
true.
not, is not teat.
Yep, just reverses the truthiness. True is false.
The book mentions short-circuiting.
Yeah, it's an efficiency thing. With Ataman, if the first part is false, JavaScript doesn't even bother checking the second part, because the whole thing can't be true anyway.
Ah, clever.
Same idea with Avanet. If the first part is true, it stops, because the whole thing is already true.
Okay. What about comparing text, strings?
Important point.
Right.
String comparison is case sensitive. Apple is not the same as Apple.
Right.
And using operators like or on strings does alphabetical comparison. but it's based on character code, so uppercase letters actually come before lowercase letters. Z is less than A.
Whoa, okay, that's a potential gotcha.
Definitely something to remember.
Is there an alternative to lots of if-else if statements?
Yes, the switch statement. It's good when you're checking one single value against multiple possible case values.
How does that work?
You have switch with the value you're checking in parentheses. Then you have case labels for each possible value, followed by code for that case.
And you need break.
Crucial. After the code for a case, you put break. This jumps out of the switch if you forget it.
What happens?
It falls through and
Yeah.
it starts executing the code for the next case as well, which is usually not what you want.
Ah, okay, so break is essential.
Unless you want fall through,
Mm-hmm.
which you can use to run the same code for multiple cases.
Okay, now, doing things repeatedly, loops.
Exactly. The for loop is a common one for repeating code a specific number of times.
It has 3 parts.
Yep, inside the parentheses, separated by semicolons. First, initialization runs once at the start, like setting up a counter let I L0.
Okay.
Second, the test condition checked before each loop run, like I10. The loop continues as long as it's true.
And third.
The increment-decrement runs after each loop iteration, like I++ to increase the counter.
And iteration just means one run through the loop code.
Correct.
Are there other kinds of loops?
Yes, while loops. They're simpler. They just keep looping while a condition is true.
So the condition is checked at the start.
Yes. And then there's do.while.
How's that different?
It runs the code inside the loop first, and then checks the condition. So it's guaranteed to run at least once.
Ah, okay. The check is at the end.
Right. And those break and continue statements work in loops too.
Break jumps out completely.
Yep. Stops the loop entirely.
And a continue.
Skips the rest of the current iteration and jumps straight to the start of the next one.
Useful for skipping certain items, maybe?
Exactly.
How about organizing code, making it reusable?
That's where functions come in. They're like named blocks of code that do a specific job.
The book uses a calculator analogy.
Yeah, think of the plus button or the square root button. Each is a function doing one task.
How do you create one?
You use the function keyword, give it a name, then parentheses, which can hold parameters.
Yeah.
Those are like placeholders for inputs the function needs.
Okay.
And then curly braces containing the actual code, the function body.
And to make it run?
You call the function by using its name, followed by parentheses. If the function expects inputs, parameters, you provide the actual values, called arguments, inside the parentheses when you call it.
Can functions give results back?
Yes, using the return statement. Whatever value you put after return gets sent back to where the function was called.
What if there's no return statement?
Then the function implicitly returns a special value called undefined.
Okay. What about where variables can be used? Scope.
Right. Global variables are declared outside any function. They're accessible from anywhere on the page.
And local.
Declared inside a function. They only exist and can only be used within that specific function.
And how long do they last? Lifetime.
Global variables live as long as the page is loaded. Local variables are created when the function starts and disappear when the function finishes, like temporary notes.
Got it. Now the book shifts to objects, representing more complex things.
Exactly. Objects bundle together related data, called properties, and actions, called methods.
Like the date object example.
Yeah, it has properties for year, month, etc., and methods like getTime or getHours to do things with the date. Much easier than calculating manually.
So there's a difference between simple types like numbers and these objects.
Yes. Numbers, strings, booleans are primitive data types. Objects are more complex structures.
But strings can act like objects sometimes.
Sort of. JavaScript lets you use object-like properties and methods on primitive strings, like getting their length. And it handles the temporary conversion behind the scenes. It's a convenience.
Okay. What are some useful string methods?
Well, length gives you the number of characters.
Easy enough.
Substring, start, end, extracts a part of the string. Caret index gets the character at a specific position.
And char code index.
Gets the numeric Unicode code for the character at that index.
Mm.
Useful for comparisons, like checking if a character is uppercase or lowercase.
Ah, because uppercase comes before lowercase in the codes.
Exactly. Then you have to lowercase and to uppercase for changing case.
Makes sense. Finding stuff in strings.
Index of search value finds the first occurrence. Last index search value finds the last. They return the index number, or nightnast 1 if it's not found.
Okay.
Split separator breaks a string into an array of smaller strings. Super useful.
And concat, join strings.
It does. But
Yeah.
honestly, the plus operator is usually easier and more common for joining strings.
Right. What about methods for arrays?
Arrays have lots too.
Hmm.
Length, again, tells you how many items are in it.
Good.
Join separator combines all elements into one big string with a separator between them.
The opposite of split? Kinda?
Pretty much. Reverse flips the array order, sorts the elements.
Alphabetically by default.
Usually, yes. But you can give it your own sorting rules if needed.
Adding and removing items.
Push item adds to the end.
Huh?
Pop removes from the end.
Shift.
Removes from the beginning.
Uh-huh.
Unshift item adds to the beginning.
Got it. Push pop at the end, shift unshift at the start.
You got it. Slice, start, end creates a new array with a portion of the original. Doesn't change the original.
Important distinction.
Concat, other array, joins arrays together into a new one. And splice is really versatile. It can add or remove elements at any position.
Sounds powerful.
It is. And finally, for each callback, runs a function for every element, just performs an action.
And map.
Similar, but map returns a new array containing the results of applying the function to each element. Good for transforming arrays.
Okay, lots of tools there. What about the math object?
Right, this isn't something you create, it's built in. It holds math functions and constants.
Like rounding?
Yep, math.round
Yeah.
rounds to the nearest integer. Math.ceil always rounds up. Math.floor always rounds down.
Your random numbers.
Math.random gives you a random decimal between 0 and 1.
Finding min-max.
Math.mac,
Mm-hmm.
you give them a list of numbers.
Powers and roots.
Math.power, base exponent for powers. Math.score RT, number for square roots. Just common math stuff.
And the date object again. For dates and times.
Yeah, digging a bit deeper. The source shows 4 ways to create one.
Which are? New date.
Gives you the current date and time.
Okay.
New date, milliseconds. Creates a date based on milliseconds since January 1st, 1970, the Unix epoch.
A specific point in time.
Right. New date, date string, tries to parse a date from text.
Mm-hmm.
And new date, year, month index, day, lets you specify all the parts.
Month index. Starting at O again, like arrays.
Yep. January 0, February is 1. Another little thing to watch out for.
Got it. And methods to get parts of the date.
Loads of them. Get full
Wow.
year, get month,
Yeah.
get hours, get minutes, get seconds, and so on.
And matching set methods to change them.
Exactly. Set full year, set month, etc.
What about time zones? UTC.
Yeah, it mentions GMT, UTC, and methods for working with that standard time, like get UTC date, get your towers, and the corresponding set methods.
Okay.
Get time gives you that raw millisecond count since the epoch. Get time zone offset tells you the difference in minutes between your local time zone and UTC.
And turning dates into text.
Several ways. The date string to local date string, which uses the user's local format, to time string to local time string. Lots of formatting options.
So ways to create objects, object literals.
Yeah, that's a really simple, direct way. Just use curly braces.
Like ball, age, 30.
Exactly. Key value pairs separated by colons. Pairs separated by commas. The book shows a create person function returning an object like this, even with function properties, methods like get full name.
And the other way, constructors.
Briefly mentioned, that's more like defining a template or blueprint for an object, say, a person constructor function.
Using the new keyword.
Right, new person. It also touches on the prototype idea for sharing methods between objects created from the same constructor, but doesn't go super deep, just notes it's another way to create objects serving the same purpose as literals.
Okay. Shifting gears. Regular expressions. Sounds intense.
They can be, but they're incredibly powerful for working with text. Think of them as patterns for searching or manipulating strings.
And JavaScript has built-in support.
Yep, the regex object. The source uses the example of replacing all single quotes with double quotes tricky without regex.
Right, so how do you use them?
String methods like search can take a regex. It finds the first match's position.
Better than index.os for patterns.
Definitely. And replace also takes regex. You can replace the first match.
Or all of them.
Yeah, using the global flag. Just a G after the pattern, like patterning.
Are there other flags?
The case-insensitive flag, I, is common. Patterning ignores upper lowercase.
Okay. Any other methods?
The regex object itself has a test method. It just returns true or false. Does the pattern match anywhere in the string? Good for validation, like checking a password format.
And split works with regex too.
Yeah. You can use a regex as the separator to split a string in really flexible ways. The example splits fruit names and prices by matching anything, not a letter.
Clever. What about capturing groups?
That's using parentheses inside your regex pattern.
What do?
They capture the part of the string that matched inside the parentheses. Then in your replace method's replacement string, you can refer back to these captured parts using $1 for the first group, $2 for the second, and so on.
Example.
Changing year 2024 to the year 2024, you capture the digits, 2024, and use $1 in the replacement. The year $1.
Cool. How do you actually write these patterns?
Two ways. Literal, pattern flags.
Yep.
Or using the constructor, new regex, pattern flags.
Is there a difference?
A key one. When using the constructor string, you often need to double escape special characters. Like a backslash need to become, because backslash already means something in regular string.
Yeah, okay. That's important.
Very. The book then walks through building a phone number, regex, explaining parts like DW, non-word char, optional NM, quantifier, OR, literal dot, start, durend.
Lots of symbols to learn there.
It takes practice, but very powerful.
Let's revisit dates and times quickly. Practical uses.
Right. Setting UTC time, using set hours, etc. Converting to strings with toTC string or toLocal string.
And timers.
Two main ones. Set timeout function delay runs the function once after the delay.
And you can cancel it.
Yep, with clear timeout. Set timeout gives you back that ID.
Okay. The other one.
Set interval runs the function repeatedly every interval milliseconds.
And you can stop that too.
With clear interval time read. The book has a conceptual clock example using set interval to update the time display every second.
Neat. Okay, moving out from core JavaScript. The browser object model, BM.
Yeah, this is about interacting with the browser window itself, history, location, screen info.
And the key thing is no standard.
Exactly. Well, HTML5 is trying to standardize parts, but historically it varied a lot between browsers.
So the advice is?
Stick to the core stuff that works everywhere for better compatibility.
What's the main object here?
The window object. It's the global object in the browser context. Represents the whole window.
So alert is really window.alert.
Technically, yes.
Yeah.
But you can usually omit window because it's global.
What's inside the window object?
Other important objects. Document, the HTML page, navigator, browser info, history, browsing history, screen display info, location, current URL.
Let's look at location. Href gets or sets the URL.
Yep. You can navigate by setting location.href.href.hol does the same.
What about replace URL?
That navigates too, but it removes the current page from history. The back button won't go back to it.
Ah, subtle difference. And reload.
Just refreshes the current page.
Okay. Navigator. Has browser info.
It does, particularly the user agent string. But the book warns against relying on it for browser detection.
Why not?
It can be unreliable or faked. Feature detection is much better.
How does that work?
Instead of asking, what browser is this? You ask, does this browser support the feature I need? Like if navigator.geolocation, to check if location services are available.
And it mentions the geolocation API, get current position.
Briefly, yeah. As an example of a feature you might detect, gets latitude, longitude.
Well, about the screen object.
Gives screen width, height, color depth. The example uses color depth to potentially set a background color.
And history.
Simple methods. Back, forward, and go in to move multiple steps.
And document in the BOM context.
We'll see more in DOM, but here it mentions setting document.bg color and the document.images collection.
An array of all images.
Like an array, yeah. You can access them by index, like document.images0, and change their SRC attribute to swap images.
So feature detection over browser detection is the key message.
Absolutely. Much more robust. The book mentions IE11 issues and the browser war's history leading to these inconsistencies. W3C helps standardize things eventually.
Okay, so now the document object model, DOM, this is a standard.
Yes, that's the crucial difference from the BOM. The DOM is a standard way to represent the HTML document structure as a tree of objects, or nodes, consistent across browsers.
What's level 0 DOM?
Just refers to older, pre-standard ways of accessing elements, more linear.
So the DOM is a tree.
Yeah, imagine the HTML tag at the root, then head and body as branches, then title inside head, maybe a table inside body, TRs inside table, TDs inside TRs. A hierarchy.
Parent-child relationships.
Exactly. And there are key object types for navigating this.
Right.
Node is the basic type for everything, elements, text, etc. Node list is an ordered list of nodes. Named node map is a collection accessed by name, like attributes.
And navigating this is different from BBOM.
Yeah. DOM navigation is abstract, tree-based.
Yeah.
You move between nodes, parent, child, sibling, without needing to know the visual layout.
Yeah.
This allows dynamic changes, adding, removing nodes.
How do you get elements in the first place?
3 main ways. Document.getElement, BI day, finds one element by its unique ID. Super common.
Okay.
Document.get elements by tag name gets a list,
Oh.
node list of all elements with that tag, like all p tags.
And by class?
Documents.get elements by class name. It gets a node list of elements with that CSS class.
Once you have an element, how do you move around from it?
Using node properties, parent node goes up. Child nodes gives a list of direct children,
Dex.
next sibling and previous sibling, also first child and last child.
And node type tells you what it is. Element, text.
Right. Type 1 is an element, type 3 is text. Useful because sometimes siblings might be white space text nodes you want to skip.
Okay. How do you change elements? Content.
Inner HTML gets or sets the HTML content inside an element. Text content, or inner text, gets or sets just the plain text.
Attributes, like SRC on an image.
That's attribute src new image.jpg.
Okay.
Get attribute src reads it. Remove attribute src removes it.
Creating new elements.
Document.createElement dv creates a new div element node. Document.createText node, hello, creates a text node.
How do you put them on the page?
Parent node.append child new node adds it at the end of the parent.
Insert somewhere specific.
Parent node.insert before new node, reference node, puts it before the reference node.
You moving and replacing.
Parent node.remove child, child node, and parent node.replace child, new node, old node.
What about changing styles, like CSS?
Two main ways. Directly via element.style.property name.
Property name, like font style.
Exactly. Note the camel case CSS font style becomes font style in JavaScript.
What's the other way?
Manipulating the element.className property. Add or remove CSS classes defined in your style sheet, often cleaner.
And animation.
Basics mentioned. Gradually changing style.top or style.left using timers, set timeouts at interval, to make things move.
Okay, that's a lot on DOM manipulation. Now, events, things happening.
Yep. User clicks, mouse moves, keys pressed, page finishing loading. JavaScript can react to these.
With event handlers.
Right. Pieces of code that run when a specific event happens on a specific element.
How do you connect the event to the code?
3 ways mentioned. First, directly in HTML attributes button on click. Can get messy though.
A second.
Setting DOM element properties in script, my button.onClick function. Better, but limited to one handler per event.
And the third preferred way.
Using addEventListener. It's the standard element.addEventListener. Click, my click handler function false.
What about older, i.e.?
You used attach event. Slightly different syntax. Element.attach event on click, my click handler function.
So you need to check which one to use.
Often, yes. Feature detection again.
When an event happens, the handler function gets info.
Yes, it receives an event object automatically. Contains details about the event.
What kind of events are common?
Mouse, loads. Click, mouse over, mouse up, mouse down, mouse up, mouse move.
And the mouse event object has details, like coordinates.
Yep. Client X. Client I for position in the window. Also, which button was pressed. Button. If Alt keys were held. Alt key. CTR key.
Keyboard events.
Key down, key press, key up.
Form events.
Submit, reset, focus when an element is entered. Blur when it's left. Change when value changes.
What's event bubbling?
Ha! Important concept. An event on an element first triggers handlers on that element. Then it bubbles up to its parent, triggers handlers there, then the parent's parent, all the way up the DOM tree.
So a click on a button might also trigger a click handler on the div containing it.
Exactly, unless you stop it.
Oh.
Using the stop propagation method on the event object.
Okay. What's event capturing?
The opposite, less common. Event goes down the tree first from window to the target, controlled by the third argument in addEventListener.
And prevent default.
Stops the browser's default action, like stopping a link from navigating when clicked or a form from submitting.
Got it. Cross-browser handling is key here then.
Definitely. Using feature detection for addEventListener versus attach event is the standard approach. And using remove event listener or detach event to clean up.
Okay. Next up, drag and drop, natively in HTML5.
Yeah. You make an element draggable with the draggable true attribute. Images and links often are by default.
And there are specific drag events.
Yep. Drag start, drag enter, drag over, drag leave, drop, drag in, a whole life cycle.
How do you pass data? Like what's being dragged?
Using the data transfer property of the event object e.datatransfer.set text my data in drag start.
And retrieve it on drop.
e.datatransfer.getData in the drop handler.
You mentioned drag over needs something.
Often needs ePrevent default. This signals that a drop is allowed here, otherwise the drop event might not fire.
So a drop target listens for drag over and drop.
Exactly. Prevent default and drag over. Handle the data in drop.
Can you move the element itself, not just data?
Yeah. Example shows getting the dragged element's ID in drag start, then in drop, finding that element, removing it from its original parent, and appending it to the drop target.
Uses query selector to find elements easily.
Mentioned as a helpful tool, yeah.
Okay, shifting to HTML forms. The main way users send info back.
Right. The form element groups, input fields, has name and EN for scripting access.
How do you access forms in JavaScript?
Document.forms is a collection of all forms on the page, accessed by index or name ID.
And elements within a form.
Each form object has an elements property. It's a collection of all the input elements, buttons, selects, etc. inside that form. Very useful for looping.
What can you do with the form object itself?
Get its name. Use methods like submit to submit programmatically, or reset to clear it, focus, and blur to, but more common on individual elements.
Let's talk about those elements. Buttons.
Input type button or button. Have value the text, name. Main event is click.
Submit and reset buttons.
Input type submit triggers form submission. Input type reset clears the form fields.
Text boxes.
Input type text. Has value, what's typed, name, size, max length. Lots of events. Focus, blur, change, select, key down, key press, key up.
Example uses value for validation.
Yeah, checking if required fields are empty on button click, using focus to highlight the missing one.
Password and hidden inputs.
Input type password masks text. Input type hidden stores data invisibly, but still gets submitted.
Multi-line text.
Text area has value, name, rows, cols. Similar events to text inputs. The event watching example probably logs the keyboard change events.
Checkboxes.
Input type checkbox. Have value, name, key property in JS is checked. True, false. Event.click.
Radio buttons.
Input type radio. Similar attributes, but the crucial thing is grouping them with the same name attribute.
So only one in a group can be checked.
Exactly. MyForm.radio group name gives you the collection of buttons in that group. You loop through it to find the checked one.
Drop-down lists.
Select containing option elements. Select has name, size, multiple. Option has value submitted and text displayed.
How do you know which one is selected in JS?
The select object has a selected index property, the index number, and often a value property, the value of the selected option. It also has an options collection.
Can you change the options with JS?
Yes. Add or remove items from the options collection. The book shows examples, maybe using the option constructor. Main event is change.
Okay. Then HTML5 added new form stuff.
Yeah, new input types like number, range, email, URL, date, and attributes like placeholder, required, min, max, step.
And the input event fires immediately on change.
Right. More responsive than change sometimes. The example likely uses number and range, updating the range slider based on the number input using the input event.
Meter and progress elements too.
For visual display, meter shows a value and a range, like a gauge. Progress shows task completion. The highway speed tracker example probably uses these.
Okay, forms covered. What about JSON?
JavaScript object notation. Lightweight data format. Very common for web apps sending data between server and client. Human readable text.
Looks like JavaScript objects arrays.
Very similar syntax, but with key differences. JSON keys must be in double quotes. No trailing commas allowed. Only primitive data types, string, number, boolean, null, plus other JSON objects arrays. No functions, no variables.
How do you work with it in JS?
The built-in JSON object, JSON stringify JS value, turns a JS object array into a JSON string.
And the other way?
JSON parse JSON string turns a JSON string back into a JS object array.
Mentions XML as older alternative.
Yeah, notes it's more verbose, harder to parse in JS compared to JSON.parse.
Okay, web storage. Storing data in the browser.
Yep. Replaces cookies for many uses, more storage space. 2 types.
Local storage.
Persists even after the browser closes. Data stays until cleared. Specific to the website's origin, domain protocol port.
And session storage.
Only lasts for the current browser session. Cleared when the tab window closes. Also origin specific.
How to use them?
Methods.setItem key value. Get item key, remove item key, clear. Values are stored as strings.
Can you access them like objects.localstorage.user baba?
Yes, that works too. Simple key value storage.
How did these relate to cookies?
Cookies are older, smaller, also tied to domain and path. Web storage is often simply for client-side JS storage.
How do cookies work with document.cookie?
You get set a single string of name value, name2, value2.
Ugh.
Setting involves specifying expires, path, etc. in the string.
As late in cookies.
Set the expiry date to the past.
Limitations of cookies.
Parsing the document.cookie string is awkward. Users can disable them. Size and number limits. Web storage is generally preferred now for JS developers.
Okay. AJAX, asynchronous JavaScript, and XML.
Right. Key idea is updating parts of a page without a full reload. Makes things feel faster, more interactive.
Like Google Maps or Suggest.
Perfect examples.
What's the main tool for this?
The XML HTTP request object. Despite the name, handles text, JSON, etc., not just XML. Originated in IE.
Basic steps.
1. Create the object. 2. Open the connection. Method URL async true. Win. 3. Set up on ready state change handler. 4. Send the request.
And in the handler.
Check ready state, want 4 for complete, and status, want 200 for OK. Then use response text or response XML to get the data.
The book wraps this setup in a function.
Yeah, conceptual HTTP request constructor. Also explained the onReady state change handler function and its scope.
Needs a web server on the other end.
Yes, something like Apache or ISA to process the request and send back data.
Example shows JS calling a PHP script.
Conceptually, yes. Client-side check email sends a request to server-side ch14 form validator.php. Response handler parses JSON using json.parse.
What's the same origin policy?
Big security rule. JavaScript from one domain, website.com, can't just request data from a different domain, another site.com, by default. Protocol and port must match too.
Can servers allow it?
Yes, using cross-origin resource sharing. Server sends special headers saying it's okay.
Older AJAX techniques, hidden iframes.
Briefly mentioned as a way to avoid breaking the back button history.
And UI feedback is important.
Crucial. Show a spinner or something while the request is happening, because AJAX itself is invisible to the user.
Got it. Working with multimedia, video and audio.
Yeah, briefly covers the history used to need plugins like Flash. Problems with that.
Now we have HTML5 video and audio.
Right. Native embedding. Use src attribute or, better, nested source elements for different formats.
Boy, a different format.
Browser support varies. H.264 works in Chrome, less so in Firefox sometimes. Need alternatives.
Attributes like controls, autoplay, loop.
Yep, common controls for playback. Poster for video shows an image before load.
How does JS control these?
Via the HTML media element object. Has properties like duration, current time, paused, ended, volume.
And methods.
Play, pause, load. Events like play, pause, ended, time update. Example shows buttons controlling play, pause, mute.
Okay. JavaScript libraries, like jQuery.
Exactly. Pre-written code to simplify tasks, especially dealing with cross-browser differences.
jQuery is a big one.
Huge. Started with Ajax, now does DOM, events, animation. Simplifies things a lot.
Examples. Creating elements, selecting.
Div creates. Hashtag myID selects and manipulates strengthened. Much shorter than native DOM.
Event handling.
I'll look at my button dot on, like function. Simpler syntax.
What's a deferred object promise?
jQuery's way, now standard JS2, to handle async stuff like Ajax cleanly. Use done for success, fail for error, always for cleanup. Cleaner than nested callbacks.
Other libraries mentioned.
General ones, mood tools, prototype older but influential. Specialty ones. Script.aculo.us for effects. Choose based on need.
What's Modernizer?
Feature detection library.
Ugh.
Doesn't add features, just tells you if the browser has them. Modernizer.geolocation, modernizer.drag and drop, etc.
Used before.
Conditional loading, using modernizer.load to load polyfills, code that adds missing features, only if the browser needs them. Test, yep, nope.
Briefly revisits prototype mood tools examples.
Yeah, selector and prototype.
Yeah.
Selector style class methods, event handling, Ajax, request and use mood tools. Just showing alternatives.
Finally, debugging. Bugs happen.
Absolutely. Part of coding. 2 main error types.
Syntax errors, typos, missing braces.
Right. Mistakes in the code structure itself.
Yeah.
Using instead of forgetting mismatched brackets.
And runtime errors.
Happen while the code is running. Maybe trying to use a variable that doesn't exist yet.
How to handle errors gracefully.
Try.catch.finally block. Put risky code in try. If error happens, code jumps to catch.
Catch block gets an error object.
Yep, with name and message. You can log it or show a friendly message. Finally runs regardless for cleanup.
But finding bugs requires tools.
Browser developer tools.
Yeah.
F12. Chrome Opera are similar. Key panels. Console and sources debugger.
Console shows errors and console.log output.
Exactly.
Sources panel lets you see code and
Set breakpoints by clicking line numbers. Pauses execution there.
then you can step through.
Yep. Step over.
Yeah.
Next line, don't enter functions. Step into. Go inside function calls.
Yep.
Step out. Finish current function. Return.
And watch variables.
See how variable values change as you step. Invaluable. Book shows basic debugger usage in Chrome Millers.
Lastly, the appendices.
Just reference material.
Yep.
Exercise solutions, lists of operators, statements, built-in objects, DOM elements, ASCII codes, useful extras.
Wow. Okay, that covers an incredible amount of ground from beginning JavaScript 5th edition. We went from the absolute basics right through to DOM manipulation, AJAX, libraries, debugging.
It's a huge landscape for sure. But hopefully this deep dive based on your source gives you, the listener, a really solid footing. Understanding these fundamentals is key.
Definitely. And we really hope those aha moments happened along the way.
Yeah, now's a great time to maybe, revisit the bits that really caught your interest. Think about those try it out examples conceptually.
Or maybe start thinking about what kind of interactive things you could build or understand better now with this JavaScript knowledge.
Exactly. It opens up so much of the modern web.
So we'll leave you with this thought. With this foundation laid, how might you now approach the dynamic interactive possibilities the web offers?
Thanks for joining us on the deep dive.